see here. I'm going to turn my video on. You gotta look at the man behind. So I'm going to pick up right where Zach left off, which is talking about a tool that is still in the development phase, but is at a point where we can run through and have something to look at the end. Let's dive on it. So I'm going to try sharing my screen here. I've got sharing options. Who can share? Only host. Oh, here we go. Okay. Okay. Can you all see this? All right. I'll take the silence as an affirmative.
Yes, I can. Sorry, I was muted.
So, talking about reflecting structured service descriptions from code. So when I'm saying structured service descriptions here, this is going to be that RPC.discover document that Zach talked about. So it's the OpenRPC document, which is a service description, and it's a structured way of describing services. And in this context, when we're talking about services, we're going to be talking about JSON RPC APIs. As Zach said, those are transport agnostic. But just to sort of give you the clue that when you see service in this context, for the most part, it means an API. We're going to be talking about API services that have already been built. So what Zach just did is to take a description following a document-driven pattern, and then use that description to generate code. And he generated a server, and as he said, you can generate clients too, and other kinds of code as well. For example, data models. But what I'm going to be talking about is code that exists. In our case, a JSON RPC API. And we're going to be taking that code and generating descriptions from that. So the really cool thing about this sort of side of the tunnel is that for services that already exist, being able to generate descriptions of services programmatically solves a lot of the challenges that developers would face or developer teams would face when thinking about service discovery. One of those challenges is man hours, because it obviously takes time and energy and learning to be able to write a service description. You need to know what the service is and how it works, what to expect from it, and you need ways to be able to validate the service once you have it, once you have the service description, to make sure that there weren't human errors along the way. So the approach that I'm taking with this library that I'm going to talk about here, called Go OpenRPC Reflect, which, as I said, but as we're saying again, is still in very early phases, but it is working to at least some extent, and it has pretty darn good test coverage at this point. So if you're watching and you're curious, please feel welcome to take a peek at this, and I would love to field questions or spend some time to loop anybody who's curious into it. But this package, Go OpenRPC Reflect, is targeted and built specifically for Go implementations. That's Golang. And reflection in this case, if you're not familiar, is a term that means meta-programming. So you're programming about programming, and what's going on behind the scenes within this package as far as reflection at a very high level is that it's using static analysis as well as runtime methods to let the code look at itself and build a structured description of itself, and then present that structured description at the RPC.discover endpoint that Zach was talking about. So that services or consumers who use the API can hit that discovery endpoint and get a lot of information about what the server or service is capable of, and use then that description to do all kinds of cool things like documentation and code generation, that kind of thing. So, so what I'm going to do is we're going to walk through let's see here. I'm going to walk through a very bare bones example of picking up on Zach's cue with a simple math idea. I've got a very bare bones RPC server set up, and we're going to use this library and plug it in and generate a server description. So let's see, I'm going to pick my next window here. All right, looks like we're sharing. Again, I'll take the silence as an affirmative.
Yes, sir.
Yep.
We're here.
Great. So first, just a walkthrough of what we're looking at. And what's going on here at the very biggest picture is that I've just written an example test, which is a Go idiomatic way of being able to provide examples as tests. So that's what we're going to do here. But there's nothing about this code that's inherently a test. That's one of the beauties of the example pattern. So what you're going to see here that already exists is just a very basic implementation of an RPC server. And the RPC server is going to be using the NetRPC package. This is a standard library package. That, by the way, also happens to use Reflect, and that's, I think, worth noting, is that this pattern of using registries and reflection in combination with structured conventions, then to then do stuff and generate stuff with that is a common pattern, and there's precedent for it in the language. So I hope that lends some credence to the initiative of the Go OpenRPC Reflect package in the first place, is because NetRPC uses reflection itself to do a very similar thing. So our service that we're going to be exposing as an RPC API is called myCalculator. And the calculator has only one method, and that is +1. And as you can see here, all it's going to do is increment the argument that's passed to it and then return that. If this method looks funny to you, it's because it is in kind of a funny shape, and it's in a shape that fits the NetRPC convention. So if you want to use the NetRPC package to register methods automatically and then be able to use that registry as a server service, then you need methods that look like this. So they need to have one argument that's a pointer and that's exported. You need to have a second argument that's a pointer and also exported. It needs to be a method that's on the receiver with a pointer, and so forth. But that's why it looks like this. Most of the time, logic in real applications doesn't use this particular pattern because it's kind of unwieldy. But for our case here, we're just going to keep the logic right inside of it. Usually people wrap logic inside of these RPC methods, but for our case here, we're just going to go with the bare bones, and this is going to be the service that we're going to provide to a server. So the pattern in Go that we're following here is to establish this this service, myCalculator, which is just assigning myCalculator a 0 value of myCalculator. And then we spin up our server, rpc.new server, and then we register our RPC calculator service onto the register. And when we do this, the net RPC package is using reflection to traverse over this receiver and look for methods that match the convention that it needs. And when it finds those methods, it registers them. And then we are going to spin up the little listener here. This is just standard Go server code. And then we are providing the server, this RPC server as the handler to our HTTP web server. And that's it. That's it for the Go server and for the actual API service. So if this were a standalone application, albeit a small one, that's all it would be. But since this is an example test, we've also got an RPC client here, and we're going to use that client to hit our server and then tell us about the responses that it gets so we can make sure that it's getting responses that we expect. So all that's happening here is we have this client, and then we're calling the client in the Go idiomatic way here, and we're expecting a reply. So if we run this test, we'll see that it's okay, that the output was indeed 43. This is a Go idiomatic way of testing the example. And that's it. So what we're going to do is use the Go OpenRPC Reflect package to install service discovery. And just a word to the wise, since I am working actually in the Go OpenRPC Reflect package itself, I'm going to be missing some import paths as I declare variables that normally in an application using this package would have. But that's a small thing, but just for the detail oriented. So the first thing that we're going to do right after we spin up our server, or at least assign our server, I should say, is we're going to create a document. This is the bare level struct here, and that's what we're going to register our receivers and methods to. So this bad boy is going to be doing the reflection work for us, and we're going to configure this, and then it's going to apply those configurations to the reflection, and eventually be able to give us a result. So there's only two things that we need to configure on this document, and the first one is the one that requires getting your hands dirty a little bit, and this is the with meta method. And the meta method, as Zach was talking about with the anatomy of OpenRPC, there are some different fields in the OpenRPC document, and the meta pattern here covers three of those fields. Those fields are the servers field, the info field, and the external docs field. And these are fields that can't be sensibly reflected. So these are application-specific data that will live in the document and depend entirely on server and application context. So this is stuff that you have to or get to fill in yourself. And you can do that as dynamically as you want. And so I'm just using autocomplete there. And so you can see this is exactly the type that it expects. So we're just going to return the bare minimum. And we're not even going to return technically a completely viable or a valid OpenRPC document at the end, because I'm not going to take the time to fill in the info section, which is required by the spec. But we're just going to get this so that the test will run. So all I'm going to do is return the func that it expects here. And this is just going to return nil and nil. And that's it. And this is going to be a func, and all I have to do is just wait for that sweet, sweet auto completion, and we can get on with things. And that's it. That's our meta registry is done. And so you can do all kinds of things here if you want. You can have mappings to the different servers if you have different servers in the application using different modules or something like that, or across different transports. You can manage info data at build time, and external docs. Of course, you can do whatever you want with that. And the next part of the configuration for this document is to register our reflector pattern. The library comes with a couple of different standard and hopefully sane default reflector patterns. But these are just reflector configurations that that fit existing implementations, like the standard library RPC convention. So all we have to do here is say standard reflector, and the standard reflector just fits the net RPC conventions. But we can do all kinds of things here with this reflector if we want. We have specific tweaks that we need for our application or for the document that we want to get out of it. We can tweak absolutely any part of this reflector. That was a significant priority building this, is so that it's totally tweakable all the way down to the nitty-gritty. You can use whatever conventions your application already has. So we're just using the defaults because we're happy with the net RPC defaults. And so here we're registering the service to the net RPC package, and we're going to use that exact same pattern registering to our document. So I'm just doing the exact same thing that I did with the standard package, and just registering that receiver. And that's it. And so now we have a document that's registered this receiver, and now we need some way to plug this document back into the RPC service that we want. So what we're going to do here is wrap this document, and this is a little bit of a magic method here, but I'll show you where it comes from. And so this RPC struct here is just totally a convenient struct, and all it's got is one document, and it's got one method discover. And this is so that it fits well with the Go convention, so that this method is going to wind up at the endpoint rpc.discover per Go conventions. But of course, this is it. And if you want to write your own implementation, you know, and include any kinds of middleware you want, you're more than welcome to do that, and it's really straightforward to do that. So now, the beauty of this is that we get to register this service back to the RPC registry. So we're registering this exactly the same way that we registered our calculator service in the first place. And that's it. That's it. So now we're on to testing it, make sure that this actually works for us. So here we were testing our +1 method, and we're going to use the exact same pattern to test the rpc.discover endpoint. So I'm just going to copy this, and instead of expecting a +1 reply, I'm going to rename this so we don't have a collision. And this is going to be a metaschema.openrpc document. And interestingly, this metaschema.openrpc document is itself a generated data model that came from one of the libraries that Zach mentioned. So we're going to get rid of our argument here. We don't need that. We can just plug right in 0 here. As you can see, this the Go RPC convention is that you have to have an argument. So we're using the simplest no-op argument here, which is 0, because the rpc.discover method doesn't have any arguments that it needs. And then since we've got a reply here, let's check it out when we get it. Oops. And since we're going to, we know that it's going to be in a JSON format because we're talking about OpenRPC, which is JSON JSON happy. We're going to marshal this. And then we're going to log it. Tidy that up. And that should do it. It doesn't look like we have any other errors here, so let's give it a run. Oops. And let's see, print line J. Aha! We weren't calling the method. Let's call that sucker. There we go. And instead of passing reply, we got to fix that. So now we can expect this to work. Well, let's see here. Discover reply, discover reply. Let's see. Aha! Let's see here. We're definitely getting some bytes, but it doesn't look like we're getting the JSON that we want. And why is that? JSON discover reply. Aha! Because we haven't cast it to a string. So JSON.Marshall indent. Let's see if I can make this any bigger for you. It returns bytes, and we want to print a string. So as you can see here, we are actually printing the document, but we're printing it in not very human readable way. So let's fix that. There we go. So we've got an OpenRPC document. As you can see, the info field is null because we didn't want to spend our time filling this stuff in. But what we do have is our calculator +1 as a method. You can see the params that it expects in the schema. You can see the result. And you can even follow this link to the source on GitHub. So if we take this server method now to bring it all the way back home, and I'm going to take just a minute and stop my screen share and switch applications. We're going to go back to our pet store. All right. So we're here at the playground. If you're watching, this is where Zach spent some time. And instead of writing our own document, we're going to just copy and paste our document that was generated programmatically right in there. And as you can see, we get very nice descriptions for our method. We got method names. We've even got the full text of the Go code that implements the method, and we can inspect the argument and check out the schemas. Good thing our linter here is checking and complaining about a null field, and that's because it expects something to actually exist. So, and now it wants us to fill it in because that's what's needed for a valid schema. But that's the long and the short of it. Again, if you have any questions or if this piques your interest, I would love to connect with you at that GitHub repository, etc labs core /go OpenRPC Reflect.